Welcome to another AI pattern recognition deep dive.
We're tackling something pretty ambitious, I think.
Definitely ambitious. Fascinating stuff, though.
Right. But maybe a little unsettling, too. We're going beyond just, what AI does.
Exactly. We're asking what AI sees, like when it looks
Yeah.
right back at us, at our world, and specifically at its flaws.
Yeah, we've gathered quite a bit of research for you looking at this from all sorts of angles. Multidisciplinary. Right.
That's the idea. Treating AI almost like a lens, you could say. A really powerful one.
And the mission today is to dive into how AI spots and then interacts with these fundamental flaws, these negative patterns.
Patterns in human systems, our society, even our evolution.
Hmm.
Maybe even bigger than that.
And there's this core tension, this paradox we need to get out right away. It's kind of the heart of it all.
Which is?
Well, AI is this incredibly precise tool, better than anything we've had before, maybe, for spotting hidden problems, systemic bias, risks we didn't even know were there.
Okay, yeah. The promise of AI, right? To find the hidden stuff.
Exactly. But here's the twist. Because AI learns from our data, historical data, data that's already full of our mistakes and biases.
I see where you're going.
It can end up just amplifying those very same flaws, automating them even, scaling them up.
So the tool designed to fix the problem actually makes it worse sometimes, or at least entrenches it.
That's the core tension. Prediction versus, perpetuation.
Yeah, that sums it up pretty well.
Yeah.
So before we get into the big societal stuff, we probably need to define our terms. What does an AI, like at the code level, actually mean by a negative pattern?
Good point. It's probably not what we mean in everyday conversation. It's much more clinical.
Right, let's start there.
Okay, so let's break it down. Purely mathematically, right? For an AI, what we're calling a negative pattern really just starts as anomaly detection.
Finding the odd one out.
Basically, yeah. The AI builds this statistical picture of what's normal, what's the expected behavior in a huge pile of data.
The baseline.
Exactly, the baseline. And anything that sticks out, anything that deviates significantly from that average.
Gets flagged as an anomaly, an outlier. Simple as that, mathematically speaking.
And this is fundamental, right? It works the same whether the AI is looking at, network traffic or stock prices.
Totally universal. Think about cybersecurity. It's a classic example. The AI learns your usual routine.
Like where I normally log in from, what times, what files I usually access, that kind of thing.
Precisely.
Yeah.
It builds a really detailed profile.
Ah.
So if you usually log in from London, and suddenly there's a login attempt accessing sensitive files from, North Korea.
Okay, yeah, that's definitely outside my baseline.
Right. It's a statistical blip, a major deviation. The system flags it as an anomaly, and in this context, humans label that anomaly as potentially negative, a threat.
Or think about finance, like credit card fraud.
Same principle. It's not usually the dollar amount itself that triggers the alarm. It's how different that transaction is from your typical spending pattern.
So if I mostly buy coffee and groceries, and suddenly there's a $5,000 charge for scuba gear in the Maldives.
Yeah, unless you suddenly took up diving, that's an outlier. It deviates from your established norm. The AI spots the abnormality. That's its job.
Okay, but this is really important, what you said about context. The algorithm itself isn't making a value judgment. It's just math.
Absolutely crucial point for you listening. The AI just identifies the deviation, the negativity, whether something is bad or dangerous or even good. That's us. Humans assign that meaning based on the situation.
Right. Like, think about a shop's sales figures. A massive spike in December.
Huge anomaly mathematically, way off the baseline from, say, July.
But it's expected, it's planned for, it's a good anomaly for the retailer.
Yeah.
Beneficial.
Now take that exact same mathematical pattern, that huge sudden spike, but see it in, like, a hospital patient's heart rate data.
Okay, suddenly very different context. Very negative.
Or in banking logs, showing unexpected money transfers. Again, same math, different context, different human interpretation. Potential fraud, potential crisis. The algorithm sees the spike. We decide what it means.
So how does the AI actually learn to spot these things? Does it need to know what it's looking for beforehand?
Well, that depends. It uses different approaches for finding known problems versus discovering totally new ones, different learning paradigms.
Okay. Let's talk about finding the unknown unknowns first, the stuff we haven't even labeled yet.
For that, you typically use unsupervised learning. This is where it gets really interesting, I think.
How does that work? You just dump a load of data on it.
Pretty much. You give the AI a massive data set, but crucially, it's unlabeled. The AI doesn't know what's good or bad or even what categories exist. Its job is just to find structure, find hidden patterns and deviations on its own.
Like a data detective, you said earlier.
Exactly. It's looking for clusters, natural groupings in the data. And then it looks for the points that don't fit neatly into any group.
So clustering algorithms are key here, like k-means. I've heard of that one.
K-means is a common one, yeah.
Hmm.
Or density-based ones like DBS can. K-means tries to group data points so that the points within each cluster are as similar as possible, minimizing the variance inside the group.
Okay.
DBS can looks for areas of high density. Points that are close together form clusters.
And the anomalies are the points left over, the ones far away from any dense region or cluster center.
Precisely, the outliers. The points that just don't conform. That's often how things like bots get flagged on social media, the lonely player bot, for instance.
How so?
Well, a normal human user has a certain pattern of making connections, posting, interacting. It forms a dense cluster in the data. A bot might suddenly make thousands of connections or post identical content relentlessly. Its behavior is statistically weird.
Yeah.
It falls way outside the main cluster of human activity. Unsupervised learning spots it as an anomaly without ever being told this is a bot.
Okay, that's finding the unknown. What about identifying the stuff we already know is bad, like spam emails?
That's where supervised learning comes in. This is more like traditional training. We do have the answer key.
So you feed it examples.
Millions of them. For a spam filter, you train it on a huge data set of emails that humans have already meticulously labeled spam, not spam.
And the AI learns the characteristics of spam from those labels.
Exactly. It learns the patterns associated with the spam label, keywords, sender addresses, link structures, whatever. Then it uses that learned model to classify new incoming emails. The negative pattern, spam, is predefined and labeled.
Makes sense. And you mentioned reinforcement learning, too.
Yeah, that's a bit different again. Think of an AI learning to play a game. It tries actions. Some actions lead to rewards, others lead to penalties.
So a negative pattern is just doing something that gets you penalized.
Essentially, yes.
Right.
It's an action or sequence of actions that results in a negative outcome according to the rules we've set. The AI learns, through trial and error, to avoid those penalized actions to maximize its overall reward. Simple, but powerful in some contexts.
Okay, so we have these different ways AI finds patterns, known and unknown. But it seems like it all comes down to prediction, right? Predicting fraud, predicting spam, predicting anomalies.
Prediction is definitely a core function, but this is where we hit that critical and sometimes dangerous shift you mentioned earlier, moving from just seeing correlation to understanding causality.
Right. Correlation isn't causation. We know this, but AI sometimes struggled with it.
Traditional AI, especially complex models, excels at spotting correlations. Event A happens, then event B regularly follows. It can predict B based on A with incredible accuracy.
But it doesn't necessarily know if A caused B.
Exactly. And often, these powerful models operate like black boxes. They give you the prediction, the what, but the internal reasoning, the why, is hidden, opaque.
Which is a problem if we need to understand the mechanism or if the correlation is misleading.
A huge problem. And this lack of why is what researchers like Judea Pearl have been tackling with causal AI. It's a push to build models that can reason about cause and effect, not just correlation.
How does causal AI try to do that differently? Is it different math?
It uses specific mathematical frameworks.
Yeah.
Things like directed acyclic graphs or DAGs. You can think of a DAG as a map of potential causal relationships.
Okay, so it's explicitly drawing arrows, like A leads to B.
Kind of. It forces the model builder to define hypothesized causal links. Instead of just observing that A and B happen together, the DAG structure allows the AI to ask what-if questions. What if we intervene and change A? Does B still happen?
So it's trying to test the links, not just observe the sequence.
Precisely. It helps differentiate between a real causal link and a situation where maybe A and B are both caused by some hidden factor, C, or where the correlation is just coincidence. It's about understanding the underlying structure.
And this isn't just theoretical. You mentioned a healthcare example where failing to grasp causality had serious consequences.
Yeah, this one is. It's a really stark illustration of the risks. A standard predictive model was looking at healthcare costs and patient outcomes, and it found a strong correlation. Lower healthcare spending seemed to correlate with less severe illnesses, which on the surface kind of makes sense, right?
Yeah, healthier people probably need less treatment, costs less.
And for a large part of the patient population studied, mostly white patients, that correlation was largely causal. Lower spending often did mean fewer serious health problems. But when the AI looked at the data for Black patients, it saw the same correlation, lower costs, and drew the same conclusion: lower illness severity. and that was dangerously wrong.
Why? What was the real reason for the lower costs in that group?
The research showed that for many Black patients, the lower costs weren't because they were healthier. They were often the result of systemic racial biases in the healthcare system itself.
Oh, wow. So things like lack of access to care or not getting the right diagnoses or treatment.
Exactly. Less access, less diagnostic testing, maybe implicit bias leading doctors to undertreat, all leading to lower recorded costs, but not because of better health. Often it was the opposite.
So the AI saw low cost and thought low risk.
Precisely. It focused only on the correlation, on optimizing the cost prediction. It completely missed the cause of the low cost, which was actually a deeply ingrained negative pattern of historical inequity and racism.
And by flagging these patients as lower risk based on cost.
It ended up recommending fewer resources, less follow-up, basically automating and perpetuating the very unfairness that created the misleading data in the first place. It mistook lack of access for good health.
That's chilling. The cause was bias, but the prediction just locked it in further.
And this ties into another risk the research points out, what some call cognitive erosion.
Meaning?
Well, if we get too reliant on these incredibly accurate predictive tools, these black boxes that just give us the what,
We might stop digging for the why ourselves.
that's the worry. We might develop a kind of cognitive laziness. We trust the machine's answer without interrogating the underlying assumptions or the causal mechanisms.
And the tool that was supposed to help us solve complex problems could actually make us less capable of the critical thinking and ethical reasoning needed to tackle them properly.
It's a risk. We become dependent on the prediction and lose the muscle for deeper understanding.
Okay, so we've got the technical foundation. Let's shift now to the human world, the social fabric. How does AI recognize and, crucially, amplify these negative patterns in society, starting with maybe the political scene? Filter bubbles seem like an obvious one.
They're a prime example, yeah.
Yeah.
And the research is pretty clear. Filler bubbles and the polarization they feed aren't just accidental byproducts, they're often systemic features.
Driven by the AI's goal.
Driven by the AI's core goal on many platforms, maximizing user engagement, keep you clicking, keep you scrolling,
But how does it do that?
by exploiting a really fundamental human tendency called homophily.
Homophily, meaning birds of a feather flock together.
Basically, yes. We
Yeah.
naturally seek out information and people that confirm what we already believe.
Huh.
Feels comfortable validating. The algorithm learns this pattern incredibly quickly. It figures out that showing you stuff similar to what you've liked before, stuff that aligns with your existing views, keeps you on the platform longer. More engagement equals more ad revenue.
So the AI isn't necessarily trying to polarize us, it's just trying to keep us engaged, and polarization is the side effect. Or is it more direct?
Well, a political economic model suggests it's more direct than just a side effect. Platforms actually find it more profitable to create and maintain these filter bubbles, especially if the population is already somewhat divided. Feeding the echo chamber works economically,
Even if the information being shared isn't reliable.
especially then sometimes. Outrageous or emotionally charged content, even if false, often drives huge engagement. The algorithm optimizing for clicks might inadvertently prioritize inflammatory misinformation over balanced facts.
And the result, this cascade effect.
Yeah, the algorithm amplifies your existing beliefs. I see stuff confirming my beliefs. You see stuff confirming yours. We drift further apart. Voter polarization deepens.
And politicians respond to that.
They have to, or they risk losing their base. Parties get pushed towards more extreme positions to appeal to their increasingly entrenched supporters. So the negative pattern isn't just the individual bias anymore. It's the AI scaling that up into these massive, hard-to-bridge societal divides.
But it's not always negative, right? You mentioned AI can be dual use. Can it fight polarization too?
There's definitely potential there. Some research is looking into what's called dynamic information provision.
Okay. What's that?
Instead of just serving static articles, think about AI-driven conversational agents. Bots, basically, but designed to persuade or inform more effectively.
Arguing with you.
Sort of, but more subtly. They can react to your specific concerns or objections in real time. If you raise a doubt, the AI can tailor its response with specific facts or counterarguments designed to address your particular viewpoint.
Ah, so it's personalized persuasion.
Exactly. And there was that study you flagged, the one about the war in Ukraine.
Right. Tell us about that.
Researchers use a conversational AI to discuss support for Ukraine with a sample of Americans. By providing tailored, fact-based information that directly address the reasons for people's skepticism or opposition.
They actually managed to reduce polarization?
Measurably, yes. It showed that the AI, if programmed with the goal of reducing polarization and armed with factual information, can identify the patterns of belief and actively work to bridge divides, not just deepen them.
So the tool itself is neutral. It depends entirely on the goal we give it, engagement versus understanding.
That seems to be the key tension, yeah.
Okay, let's pivot to the economy, another area rife with patterns. We hear a lot about AI and jobs, wealth concentration.
Yeah, the automation paradox is a big one here. AI is incredibly good at automating routine tasks, both physical and cognitive.
Which often means tasks done by lower skilled workers.
Disproportionately, yes. Those roles become, in the rather cold economic terms used, superfluous or extrafluous. They're automated away.
While at the same time,
The people designing, implementing, managing, and investing in these AI systems, often already high earners in tech or finance, see significant productivity gains and wealth increases.
so AI acts like a pattern matching engine that heavily rewards capital and very specific high-level skills driving inequality.
The data strongly suggests that. We see the top percentiles capturing huge wealth gains while the bottom half stagnates or sees very little benefit. Even economic forecasts that predict overall GDP growth from AI usually also predict this widening gap, this concentration of wealth.
But the economic risk isn't just about who gets rich, is it? There's a systemic danger too. You called it the micro-macro disconnect.
Right. This is subtle but really important. AI is fantastic at managing risk at the micro level, like within one company, one investment portfolio. It can optimize wonderfully based on the available data for that specific entity.
Okay, making individual banks or funds safer, more efficient, sounds good.
Sounds good. But the problem arises when every major financial institution adopts the exact same AI-driven risk management techniques, the same best practices all at once.
Everyone optimizes in the same way.
Exactly. It leads to a dangerous monoculture across the entire financial system. Everyone is using similar models, looking at similar data, reacting to market signals in the same programmed way.
Which makes the system efficient, day to day maybe, but also brittle.
Incredibly brittle, because if everyone is optimized against the known risks in the same way, the whole system becomes terrifyingly vulnerable to the same unforeseen shock, the unknown unknown.
One domino falls.
The reaction is correlated across the entire system because everyone's AI reacts similarly. It can trigger automated sell-offs, liquidity crises, a chain reaction that spreads much faster than humans could manage. Individual stability creates systemic fragility.
And you mentioned AI struggles with certain types of risk too.
Yeah, AI is generally better at managing exogenous risk stuff that comes from outside the system, things you can measure like commodity price shocks or natural disasters.
Okay.
But most major financial crises, like 2008, weren't primarily caused by exogenous shocks. They were driven by endogenous risk.
Risk created inside the system.
Yes. Risk created by the complex, often unquantifiable interactions between the players in the system. How leverage builds up, how interconnectedness creates hidden dependencies, how incentives lead to unexpected collective behavior.
Stuff that's hard to put neat numbers on.
Very hard. And the AI, focused on optimizing the measurable known risks within each institution, might completely miss the buildup of this unquantifiable endogenous risk across the network. It might even contribute to it by encouraging herd behavior.
So it's optimizing the parts while potentially destabilizing the whole, focusing on the wrong kind of risk.
That's the danger. It draws attention and resources to managing the known, while the really catastrophic risks might be building quietly in the system's structure, driven by the interactions the AI isn't designed to fully grasp. The 2008 subprime crisis, with its complex web of derivatives and hidden counterparty risk, is a perfect example of that endogenous risk blowing up.
That pattern optimization creating monoculture and fragility seems like a recurring theme. Let's look at justice and inequality now. This feels like maybe the most direct harm from biased AI.
Predictive policing is probably the most cited and maybe most troubling example of an AI amplifying negative historical patterns.
How do those systems typically work?
They're usually trained on historical crime data, arrest records, incident reports, calls for service, going back years, sometimes decades. The goal is to identify geographic areas or even individuals likely to be involved in future crime hotspot.
Okay, sounds logical on the surface. Use past data to predict the future.
But the huge fundamental flaw is what that historical crime data actually represents.
It's not necessarily a map of where all crime happened.
Exactly. It's primarily a map of where police activity has been concentrated in the past.
So if certain neighborhoods, often minority communities, have been historically over-policed,
Then the data will show more arrests, more reports, more police interactions in those areas, regardless of the underlying crime rate compared to other areas. The AI learns this pattern.
it learns the pattern of policing, not necessarily the pattern of crime itself.
Precisely. It absorbs the historical bias baked into the data. So the algorithm flags these historically over-policed communities as high risk.
Which then justifies sending more police resources there.
Right. Which naturally leads to more arrests, more citations, more stops in those same areas, simply due to increased police presence and scrutiny.
And that new data.
It's fed back into the algorithm, reinforcing the initial prediction.
Yeah.
See, we told you it was a high-risk area. It becomes a self-fulfilling prophecy, a closed feedback loop.
Automating and scaling historical injustice, turning past bias into future risk scores.
That's the cycle. And we see the real-world impact when we look at specific algorithms used in the justice system.
Like the Compass algorithm, that one got a lot of attention.
Yeah, Compass is used in the U.S. to predict the likelihood of a defendant reoffending, but investigations found it was significantly biased against black defendants.
How so? It wasn't accurate for anyone.
It had similar overall accuracy rates for black and white defendants, but the types of errors were racially skewed. It was much more likely to wrongly flag black defendants as high risk for reoffending false positives than white defendants.
While simultaneously being more likely to wrongly flag white defendants as low risk, false negatives.
Correct. So it essentially encoded the societal bias, making errors in a way that disproportionately harmed black individuals, potentially leading to harsher sentencing or denial of parole based on a flawed, biased prediction.
And this isn't just a U.S. problem. You mentioned a system in Germany.
Right, the passenger name record, PNR system. It's used for mass surveillance, analyzing flight passenger data to supposedly flag potential threats.
Sounds like high stakes. How accurate was it?
A mandated audit, a manual check, found the accuracy rate was, well, staggeringly low, just 0.3%.
Wait, 0.3%? That can't be right.
That's what the check found. Out of about 94,000 algorithmic flags or matches, only 277 turned out to be correct upon human review.
So 99.7% of the time, the system was wrong. How is that even useful? Why keep using it?
That's the deeply concerning question, isn't it?
Yeah.
It suggests that sometimes the perceived value of having a predictive system, the feeling of doing something, might outweigh the actual need for accuracy or fairness.
Even if it means thousands of innocent people are flagged, questioned, surveilled.
Effectively treated with suspicion based on an algorithm that's almost always wrong. And because the system is often a black box, challenging why you are flagged is incredibly difficult. It's what some researchers call algorithmic possession of a biased narrative.
Meaning the algorithm kind of owns a distorted view of reality.
Yeah, it codifies this skewed perspective based on flawed data or faulty correlations and presents it as objective truth. And fighting that objective-seeming automated judgment is incredibly hard.
Okay, let's zoom way out now. Beyond current society, looking at how AI interacts with even more fundamental patterns. Biology, evolution, maybe even the universe itself, starting with our own genes.
Genomics is definitely an area where AI is having a massive impact. Models like DeepMind's AlphaFold for protein folding, and now things like AlphaGenome.
What can AlphaGenome do?
It uses really advanced AI techniques, convolutional layers, transformers, the stuff driving large language models to analyze incredibly long DNA sequences. We're talking up to 1 million base pairs.
And what does analyzing that tell us?
It allows the AI to predict the potential impact of tiny changes, even single-letter mutations, across thousands of different biological processes simultaneously. It's about understanding the downstream effects of genetic variations.
Which sounds amazing for medicine, right? Predicting disease risk, personalizing treatments.
Phenomenal potential, absolutely. But like with all these powerful predictive tools, it immediately raises the specter of negative patterns. In this case, discrimination and inequality.
How so? Based on your genetic makeup?
Precisely. Once we can accurately predict predispositions, not just for rare diseases, but for common conditions, maybe even complex traits related to intelligence or behavior.
Then who gets that information? And how is it used?
Exactly. Could it affect your job prospects? Your ability to get insurance? Your social standing? The potential for genetic discrimination becomes very real.
And it creates a new kind of inequality, doesn't it? Beyond just wealth.
It really does. A new axis. The genetically informed haves versus the have-nots.
Meaning your future health and opportunities might depend not just on your genes, but on whether you can afford the sophisticated AI analysis and the personalized interventions it might recommend.
Right. It ties your biological destiny even more closely to your socioeconomic status. Access to the AI insights becomes a form of capital.
And looping back to that idea of cognitive erosion, if AI gets deeply involved in managing our health, even predicting our futures based on genetics, does that change us?
That's the more speculative long-term question. If AI becomes a constant partner in decision-making, anticipating our needs, guiding our choices based on biological data,
Do we become less capable ourselves? Cognitive laziness, as you put it.
it's a concern. Over-reliance could potentially lead to a decline in certain human cognitive skills. Critical thinking, complex problem-solving, maybe even emotional intelligence or ethical reasoning. We might become passengers in our own lives, less equipped to handle the very complexities AI introduces.
Which leads into some really far out ideas about human AI coevolution. AI not just as a tool, but as a permanent part of us.
Some theoretical models explore this, yeah. A shift towards what they call an integrated evolutionary individual.
What does that even mean?
It suggests moving beyond tool use to a kind of symbiosis, or even interdependence. Humans provide the biological platform embodiment, reproduction, while a vastly powerful, perhaps decentralized AI acts as a shared informational core.
Like a collective brain, managing memory, coordinating behavior for the species.
Something like that, optimizing things on a scale we can't imagine. Information and capabilities developed by the AI could potentially be shared or integrated across the population almost instantly, a bit like Lamarckian evolution, bypassing slow biological change.
Okay, that's a lot to process. But the ultimate negative pattern here, the big sci-fi fear, is the singularity, right? When the AI becomes uncontrollable.
That's the endpoint concern, yeah. Based on I.J. Good's idea of an intelligence explosion.
The recursive self-improvement loop.
Right. An AI designed to improve its own intelligence could reach a point where it rapidly surpasses human intellect, entering a runaway feedback cycle. We get superintelligence.
And the danger isn't necessarily that it turns evil, like in the movies.
Not necessarily malice, no. The more plausible danger, according to many researchers, is goal misalignment.
Meaning its goals just aren't our goals.
Exactly. A superintelligence would likely see human conflicts, our inefficiencies, our environmental destruction, our biases as just deeply illogical, suboptimal patterns.
And it might try to fix them.
It might try to optimize the world according to its goals, which, even if they seem benign initially, like maximizing happiness or stabilizing the climate, could have catastrophic unintended consequences for humans if our values aren't perfectly encoded, which seems almost impossible.
It's the ultimate monoculture risk again. Optimizing for one thing at the expense of everything else we value. A structural loss of control.
That's the fear. Not being conquered, but just becoming irrelevant or accidentally eliminated in the pursuit of a non-human objective.
Okay, bringing it back from the brink slightly. AI is also being used to look for patterns on the truly grand scale, out in the cosmos.
Absolutely. Astrophysics and astrobiology are huge users of AI now.
Looking for life.
That's one key area.
Hey.
AI algorithms sift through unbelievable amounts of telescope data light spectra, atmospheric compositions from exoplanets looking for anomalies, biosignatures.
So it's doing anomaly detection again, but looking for signs of life as the outlier against a non-living baseline.
Essentially, yes, searching for patterns that deviate significantly from what we expect from purely geological or chemical processes on other worlds.
And it's also helping us understand the universe's structure.
Definitely. Take galaxy classification. Frameworks like Morpheus use deep learning to analyze images pixel by pixel, automatically identifying galaxy shapes, spirals, ellipticals, irregulars.
Something that would take humans forever.
Centuries, probably, to do it at the scale AI enables. This automation helps us understand how galaxies form and evolve over cosmic time, revealing large-scale patterns in the universe's development.
It feels so removed from human bias. But you mentioned a connection back to human choices. Even here, the universal filter idea.
Yeah, it's a nice parallel. Even as we use AI to scan the cosmos, researchers are thinking about how to control AI safely here on Earth through similar filtering ideas.
How does that work?
There was work done at Oxford, for example, showing that if you carefully filter the AI's training data, removing information about dangerous capabilities, like how to engineer bioweapons or advanced cyber attacks,
You can make the AI less likely to develop those harmful skills itself.
that's the finding. You can create models that are inherently resistant to acquiring certain dangerous knowledge, simply by curating their input.
So even when we're talking about galactic scale AI or superintelligence, it still comes back to the data we feed it, the choices we make in its design.
Ultimately, yes. The human element, the curation, the goal setting, remains the critical factor, whether the scale is local or cosmic.
Okay, we've covered a lot of ground. Technical definitions, politics, economics, justice, biology, even space. Let's try to pull it all together now. This idea of a consequence cascade.
Right, because none of these negative patterns exist in isolation, do they?
Yeah.
The research really emphasizes that they link up, they reinforce each other in feedback loops.
Can you trace one of those loops for us?
Sure. Let's start with economic inequality, driven by AI automation.
Okay, automation concentrates wealth and skills at the top.
Right. That concentrated capital then allows those wealthy groups or corporations to develop and deploy even more sophisticated AI for managing wealth, for influencing markets, for information control.
Ah, so the rich get richer AI.
In a sense, yeah. And that superior AI capability can then be used to shape the information landscape more effectively. Get more advanced filter bubbles, more targeted messaging, maybe even manipulating online discourse.
Which then reinforces the political power and ideological outlook of the group that controls the best AI.
Exactly. And that political power, combined with the underlying biases reflected in the data they use, then gets encoded into automated systems used in society.
Like the biased predictive policing or healthcare algorithms we talked about.
Precisely. So you have this loop. Economic inequality fuels better AI for the few, which shapes information and politics, which then gets baked into automated systems that perpetuate the original inequalities. It's a tightly wound cycle.
And the core paradox we started with is just sitting right in the middle of it all.
Laid bare, really. The tool designed potentially to help us understand and fix systemic flaws.
It is actually acting like an accelerant, amplifying those flaws because it's learning from our biased past, holding up a mirror, but a mirror that automates the reflection.
It forces us to confront the source of the patterns, which is usually us, our history, our systems.
So the big question then becomes, what do we do? Are we just passengers on this AI train heading towards amplifying all our worst tendencies?
The research strongly suggests no. It's not predestined. The trajectory isn't baked into the silicon itself.
It depends on our choices.
Entirely. It comes down to the ethical frameworks, the political will, the moral choices we make now as we develop and deploy this technology.
And we're at a fork in the road, basically.
Feels like it, a real bifurcation point. We can carry on the current path, deploying AI primarily for narrow goals like maximizing profit, efficiency, engagement.
Which likely means more inequality, more polarization, more systemic risk, like that monoculture fragility.
That seems the probable outcome of that path. Or we could consciously choose to reorient, to prioritize using AI for the really hard, complex problems that benefit humanity as a whole.
Like what?
Like tackling climate change modeling, discovering new medicines for intractable diseases, creating truly personalized education, maybe even finding ways to reduce bias and inequality, shifting the objective function away from pure optimization towards human welfare.
But that requires actual oversight, right? We can't just hope corporations choose the welfare path.
Absolutely not. It requires proactive governance, strong legal and regulatory frameworks.
Especially demanding transparency, getting rid of the black box.
Transparency and accountability have to be paramount, especially in high-stakes areas. Medicine, justice, finance. We need systems that are explainable, auditable. We need to be able to see why the AI made a decision so we can catch and correct biases before they cause widespread harm.
So AI doesn't make human judgment obsolete. It actually makes it more important than ever.
That's the ultimate takeaway, I think. AI is an incredible tool for pattern recognition. It can see correlations, deviations, structures in data that we could never find on our own.
But it can't provide the wisdom.
Exactly. It doesn't have inherent values. It doesn't understand context in the human sense. We have to provide the ethical baseline. We have to curate the data thoughtfully. We have to interpret the patterns it finds and decide what they mean and what to do about them. The AI finds the what. Humans must still provide the why and the what should be.
It amplifies our intelligence, maybe, but also our responsibility. #tag outro.
So wrapping up this deep dive, we've seen how AI identifies these negative patterns, often starting as neutral math, but becoming deeply problematic through context and biased data.
Yeah, from the correlation trap blinding us to real causes, like in that healthcare example.
To the monoculture risk-making systems fragile, like in finance.
And the devastating feedback loops that automate injustice in policing and beyond.
The common thread is AI learning from and often amplifying our existing human or systemic flaws. It's holding up that mirror, as you said.
A very powerful, very fast mirror. And the reflection it shows, the future it predicts based on our past. It's not always pretty.
Which leaves us, and you listening, with a final thought to chew on. A provocative question, maybe.
Go for it.
If we accept that AI's impact is fundamentally shaped by the baseline data, the human systems it learns from,
Okay.
then which specific human system, our politics, our economic structures, our justice system, needs the most radical redesign before we fully integrate the next, even more powerful generation of AI?
Wow. So not just tweaking the AI, but fixing the underlying human system first.
To ensure we're building on a foundation of equity, fairness, and sustainability, not just automating and accelerating the flawed patterns we already have. What needs to change in us before the AI locks it in?
That's the challenge. What baseline are we building?
Something to think about.
Definitely. Thank you for joining us on this deep dive. We hope it gave you plenty to consider about the patterns AI sees and the patterns we need to address in ourselves.
Thanks for listening.
Searching for answers to unanswered questions.
This is DigitView.